Hey guys, today we're doing Chapter 2, Section 2, which is on linear models and correlation. So for this section you need to make sure that you have a graphing calculator. I prefer to use a TI-83 or a TI-84 because we're going to be using our calculators to come up with linear models. So, on your notes, we have linear function. That's a set of ordered pairs x, y, which can be described by an equation of the form y equals mx plus b, where m is the slope and b is the y-intercept. Basically, if you can write something so that it only has a y and an x, and there's no x squared or x cubed or x to the fourth or anything like that, and there's no other weird like variables as exponents or anything, that would be considered a linear function. What we want to do is use the regression capabilities of our graphing calculator to find a linear model of the table below. So we've got our data points here. Our independent variables are year, and our dependent variables are CPI values. So our x values are a year, and our y values are our CPIs. What I'm going to do is go into my graphing calculator here, and I'm going to hit Stat, and then I'm going to go to Edit. Okay, and what I'm going to do is enter these values into my table. So my L1, that's my list 1, that's where I'm going to put my x values, and my L2, or my list 2, is where I'm going to put my y values. So I'm just going to go through and enter my data real quick. Alright, now that I have all of my data entered into my list 1 and my list 2, I can ask my calculator to come up with a linear regression. So what I'm going to do next is I'm going to hit Stat. Sorry, my calculator's not responding. Then I'm going to arrow over to Calc. I'm going to go down to number 4, which is linreg ax plus b. That stands for linear regression. So basically that's going to give me some sort of linear equation to model this data. I'm going to hit enter, and then I'm going to hit enter again. Okay, your screen might be a little different. Basically you just need to enter through it. Okay, and then what it tells me is that if you have the equation y equals ax plus b, your a value would be 4.769, your b value would be negative 9,361.5, and then it gives me an r squared or an r value. If your calculator does not have an r squared or an r value, what you need to do is hit second and then go to 0, which is catalog. Okay, then you want to go to D, which is this little x to the negative 1, and it'll go down to all the D's here. Okay, and then you want to arrow down until you find diagnostic on. And you want to hit diagnostic on. Okay, so now that has created the R values for you. So you can go back in to Stat, Calc, Lin regression, and then it'll now give you the R values. So that means that my equation now is going to be y equals 4.77x minus 9,361.53. Okay, so my calculator gave me an equation for this set of data. Now that R value is called the correlation coefficient. Basically, it's a measure of strength of the linear relationship. Okay? Remember that if your R value is greater than or equal to 0, that means that you have some sort of positive relationship. Okay? In other words, you have like a positive slope. Okay? If your R value is less than or equal to 0, that means you have a negative relationship, which is a negative slope. If you have an R value of 1 or negative 1, that means that you have a perfect relationship, meaning that all of your data points lined up exactly the way you wanted them to. Okay? If you have a R value that's close to 0, or maybe like between negative 0.5 and 0.5, that's a really bad correlation. So that means that your model is not a very good model. Okay, so the closer the absolute value of R is to 1, the better your model is. Okay, remember that the negative doesn't really matter because the negative just represents the whether it's a positive or negative relationship. So if the absolute value of r is close to 1, then that's a good relationship. All right, that's everything for section 2.